Good morning, everyone. And yeah, this is moving fast and securing things. So we're going to talk a bit about the SDLC that we use, a tool that we've worked on that we will be open sourcing. A bit about ourselves. I'm Max. Zach and Tripper, you met. We're all on the product security team at Slack. So we work on app reviews, feature reviews, etc. Run the bug bounty. And so today we're going to talk a bit about what we do in our deployment process, how that will probably generalize to your workplaces or your organizations. We're going to talk about our secure development lifecycle process, what we've implemented, what we've seen that works, what doesn't work, the feedback we receive from that, and the lessons learned. And when we discuss the tool, we'll talk a bit about the architecture of that as well, and we'll be open sourcing that. So, if you haven't heard of Slack, it's a messaging app for teams. We do collaborative, it's a collaborative platform. We're about 4 years old, and there's a web browser app. We also have a desktop and mobile app, so our attack surface is kind of one central API that a handful of web or Electron apps are hitting. We have a high amount of user growth. This is a bit old. Right now we're at about like 5 million daily active users, so it's a pretty rapidly growing company, and I hope that sets the stage of this rapid growth and how, through this presentation, we'll see how we're able to scale our SDL, because as you see here, this is our full product security team. So the three of us are product security for an organization that's growing very rapidly, or a company that's growing very rapidly. About half of our daily active users are outside of North America. The top 5 countries are the UK, Japan, Germany, France, and India. This may not seem immediately relevant, but we'll come back to it when we talk about our bug bounty as a source of feedback for the success of our SDL. We have about 3.5 million simultaneously connected users. So one of the constraints we'll discuss is how we can't have much downtime. I mean, no one wants downtime. But when you have a lot of actively connected users, you can't turn things off and turn them back on again. And the average for all of our daily active users is approximately 10 hours per week. So in 2015, we were about 400 employees, and now we're more than double that. We're growing at an extremely quick pace, a bunch of offices, engineering, and the development organization is also growing at a rapid pace, and it's growing much faster than ProdSec. So we've been about 3 people for the last year or so. We recently hired a 4th as our manager, but the graph of ProdSec looks kind of like flat line, and the graph of our employment of engineers looks like something that doubles over time. So we need to be able to address that through our automation and our process. So the engineering organization has tens of billions of database queries per day, approximately 100 gigabits per second of database network traffic, at peak petabyte of storage, hundreds of database servers, and this culture of continuous integration and continuous deployment. So app developers handle development to the pull request to deployment, and they can do it in about 10 minutes. So from you getting access to GitHub, you can author, commit, and push to production extremely quickly. So I've got a question for the audience. How many of you, raise your hand if you deploy to production once a month? Raise your hand if you, what about once a week? More than once a week, let's say once a day. 10 times a day? 100 times a day? 1,000 times a day? Okay, so Slack deploys to production approximately 100 times per day. So these are individual authors developers who are committing their code, deploying, and 100 times a day we have things reaching production. And we have a culture of no security gate at deployment. So every code push every individual push doesn't require the approval of us, the security team. Security is more of an opt-in process rather than blocking. And as far as our onboarding experience goes, the security training, we have an initial one, and then the more in-depth one is a few days after you join. So you already, on your first day, have an exercise to push code if you're a developer. So there's kind of a constant culture of quick deployment, move fast, push code to production, and don't put blockers in place. So you may have seen this picture describing the relationship between DevOps and security. We think that's a bit of a downer, and ideally the relationship doesn't have to be like that. Ideally, going through RSDL is a bit more like this. More happiness, less trouble. So, what is the SDL? It's the Secure Development Lifecycle. You might see SDLC, you might see other acronyms for it. Rose putting another name. This may be familiar to you if you've worked with Microsoft, Juniper, Adobe. A lot of places use this as a model. And this is Microsoft's approach to the SDL. So there's training, the requirements, the design, implementation, verification, release, response. And it highlights security topics throughout numerous stages and phases of development. But if you start talking about secure development, if you show a graph like this that's very one stage at a time, it looks a little bit slow. If you mention the word life cycle or process, people's eyes might start to glaze over. They might start to become worried that this fast and frictionless environment of pushing code all the time might come to an end. And adding friction doesn't always work well with always shipping a contract. So to deploy the SDL at Slack, we had a lot of work to do. We'll talk about lessons learned, but we've been deploying it. It is deployed. We continue to build it. We continue to try and improve it. But when we first started, it was a lot of work to do, and not a lot of time, and not enough resources. And I'm sure we all have this problem in some way or another. And while we have excellent developers, inspiring security is, and thinking about it, is sometimes a bit difficult, or can be derailing to a team's output. So we deploy code multiple times per day. Our company's growing very fast. Waterfall, SDL doesn't totally work in our process. So what do we do? The first thing we did was to follow a process of transparency and make our processes transparent to everyone in the organization. So we want to have a process that isn't scary, that's understandable, and has a visible scope from the outside. So this involves documenting things. It involves keeping things discussed in an open forum. And it moves the power back to the developers, who are awesome and care a lot. Like, our developers are great. They're very interested in building a secure product. Sometimes product security has a more specific knowledge, but if we can foster that relationship, we can both build each other up. So, and developers also have that knowledge of where the risk is. They're the ones writing the features. So for us at Slack, we use Slack, so our discussions take place in Slack. Other messaging applications, other places can work for you. But that transparency has been vital to our SDL being deployed and appreciated and used by our developers. We also have insight through that into what other developers work on. So it's also worth noting that this didn't come out of a vacuum. We're standing on giant shoulders here. So this comes from a free ebook from Microsoft. It was simply not going to be possible for a small team to conduct sufficient design and code reviews to materially improve the security of the next Windows release. So instead of fishing for security vulnerabilities on behalf of the product groups, the SWI team would teach them how to fish. And that's the Secure Windows Initiative team. So with that in mind, we also have a culture of trusting our developer, and we've tried to build that further through our SDL. We expect good security from the application development team, but we want to help enable them to be secure by default. We don't see our developers as not being capable of writing secure code. We don't see this as a hand-holding thing. We want to trust them so they trust us. We have mutual trust between our organizations. Security is the responsibility of everyone at a company, at an organization. And we're here to help people do it correctly. So one of our biggest goals is to make the development teams be security self-sufficient so that we can focus on harder problems. So with this culture of trust that we have, we're trying to have transparency and availability. So we have an open forum, we have open discussions. We also host security office hours. This is a big thing we recommend. So once a week, we have an hour-and-a-half session where anyone can drop in and they see the team, they get to ask us questions. We're also available on Slack. For onboarding, we do discuss security topics. We do present our security team as the faces of the team, as people who are there to help. And all of this builds up to a mutual trust. We don't want an adversarial relationship. If security is seen as an adversary, which happens all too often, accomplishing your goals becomes extremely difficult as a security team or as a developer. Developers see security as a roadblock. Security sees developers as people who are trying to put RCE into production. And with that, I'm going to hand it over to Zach to continue this discussion.
Thanks, Max. So the self-service SDL is the tool that brings it all together. It allows the developers to produce at high output with very, very low friction. It enables us to scale a rapidly growing engineering organization while still remaining only three people. And it begins with the initial risk assessment. It allows developers to self-eyeball their feature or product's own risk before it even reaches the security team. To put it simply, developers know their code best. They know if their code is going to have a high impact, such as if it touches an authentication framework. And they know that they know their code best. So they'll be able to get that risk rating back and see what how severe it's actually going to be. It starts with a few simple questions. Depending on your answers to those questions, it'll continue to generate more questions until you actually get that risk rating. If you've ever seen vendor security questionnaires, such as ones from Google, it's very similar to that. So it's a component-based survey that allows experts creating software to scope the survey to their needs. And by default, it gives an array of opted-in SDL content. Key thing here regarding the architecture, it's a plugin-based architecture. It's not just meant for us to slap. It's meant to be a more general tool that can be extended upon. It's easy to do intake of requests. If you add a new language, it's as simple as adding another plugin. And it shifts the burden from thinking about insecure coding to just thinking about it at a high level. And as you can see here, these are some of the questions that might be asked during the component survey. Each of these primary modules can have additional sub-modules that are asked. Say, for example, when we ask the developers, are you writing code in PHP? We want to be able to give them PHP-specific guidance. We don't want to waste time showing them information about memory corruption in C. And as you can see, we also have some preset tags here for things that might be commonly worked on in Slack, such as the message server, the iOS, and Android apps. When you go through this list here, software experts themselves are identifying the risk. Like I said, they know most about where their code is likely to break. This shows some additional questions that are asked here and kind of highlights a little bit more that we really don't want to waste time talking to the developers about things they already know about or things that are completely irrelevant to the project. So if they're going to be doing XML parsing, we want to give them guidance and advice on XML external entities. We don't want to be giving them advice about output coding for cross-site scripting. So how do we deliver these kind of expert checklists best to the engineers? How do we build upon this idea a bit more? How many of you have seen one of these shows or something like it? Depending on where you live, it might be called something different. The idea and the premise for all of them is the same. It's about air crash investigation and how to prevent it in the future. So it turns out checklists are one of the primary methods for preventing aviation accidents, simply because most aviation accidents are the result of human error as well as not following the checklist. Now, can we use this idea, this concept, and apply it to software development? What are some of the ways that we can address these software accidents? It turns out, in our case, we add oversight of the completion of the SDL in the process to our product team shipping requirement list. Us as a product security team checks the work of the developers to ensure the SDL is actually completed. That the developers know what questions they're answering, that they understand them, that they're not running through the list and checking off every item. We make the tasks as simple as possible and try to formulate the questions more statements rather than questions. Developers should easily be able to run through it as a checklist. Yes, we're using PHP. Yes, we're going to use this library or this framework. Not complicated questions about the project's architecture. We want to give them specific tailored advice to the type of code they're writing. We also have built-in feedback loop via the bug bounty system. So we know if we get a lot of bugs that come in through HackerOne that aren't addressed in this checklist, it needs to be changed. It needs to be updated. This is not something that we put in place and then completely ignore and tell our developers we have to run through all of this. It should be a conversation between you and your developers. So if you have a developer that comes to you and says, you know what, I'm working on this project, but I'm writing it in Go and none of this applies. Our answer would be, yeah, you're right. We need to update this. It needs to be changed. So for some of our checklists, we actually used Trello in the past for our engineering organization, but that was moved over to Jira. The SDL process lagged behind a little bit, but we found that when we actually updated our SDL code to creating tasks in Jira, we saw increased adoption of it. The key benefit of that is you don't want developers to go back and forth in between using multiple tools. You want to meet your developers where they're already working if possible. And this is what the generated Jira checklist looks like after you fill out the component survey. The key thing here is it's a standard Jira task. You can track it in the same way that you normally do. You can add, in our case, we actually added as a blocker for Jira Epics, so teams know what things they need to complete before they ship their features. And if you go under, say, the SDL General tab, these are some of the questions and checklists that will be generated. This is very important because it gives us insight not only to the team itself, but also the feature that's being developed. So say a feature is about to be released and the team's checked off every checkbox except for one. It's called input validation and output encoding. It's possible that the team just didn't understand that question. So we can focus our efforts and our time on explaining that concept to the team instead of running through this checklist with them one by one. Or sitting in a feature review meeting and just asking them really long, generic questions about things they already understand. It helps us train teams better as well as track their understanding of it. And this is what it looks like when it's actually completed. On our side, it's very easy to simply go through the list and see if a team has completed every item on there. We'll talk about this a little bit more and hand it off to Vickery.
Thanks, Zach. So, as we've seen through all of these steps in the process, from the risk assessment, and then go to the component survey, and in the end, completing the checklist. So all of this activity are done by the development teams. So we have a self-service SDL, the development team, they can start the SDL process, and they can also complete by themselves. But that does not mean that the security team is off the hook. So we have a task. We wanted to make sure that the development teams go through the process without any issue, or if they have any blocking state to complete the checklist, so we need to help them. So that's why the security team is here to help. And how do we help the development teams? So for every single SDL submission, we will receive a notification, something like this, on our channels. So this gives us some kind of like heads up on what are the things that is coming up, like what type of feature that will be coming, and what is the things that the developer is currently working on. And it also have a risk rating. This risk rating is actually based on the initial risk assessment on the previous steps. So we use this risk rating to prioritize our work because we will receive like so many SDL submission, and we need to prioritize like which one that we wanted to look first. So this is actually a link to a Jira ticket, and inside of the Jira ticket, usually we already have all of the necessary information that we need to perform a security review on the feature. So it might have like a technical specification or design specification, so things that might be added to the products or things that might be changed on the products. So if the developer they wanted to introduce a new API, it will have that list of API that they will introduce. So for us as a security teams, when we look on this document, so we already know which area that we wanted to take more. So usually it has an API, we wanted to make sure, hey, is this API has like a user input validation or not, or maybe what type of access control list that is need to be in place on that API. So inside of this, we also have to link to the checklist. So we will do review to the completion of the checklist to see like how the developers going through the checklist, whether or not they can complete the checklist, or is there any blocker of the checklist, and if there is anything that need to be follow up, we can reach out to the developer, have a meeting with them, and see if we can find a solution for their issue. And sometimes we also have a link to the pull request or PR, and we can do that. With that information, we can do a manual code review on the code. So basically, the security team is got looped in through the feature development by this process. Now, we also have what we call the triage security product channel inside. So this is a triage channel. This is a place for everyone to ask questions to the product security teams. But throughout our organization, we have multiple triage channels, and it has different purposes and also for different teams that's using it. This one is specific for the question to the security product security teams. And so yeah, through all of these triage channel, we follow this same guideline where we start, if we wanted to ask a question or request something to the teams, we start with the circle emoji here. So we use that for determining what is the urgency of the request and what is the priority of the request. We use a 3 different color, white, blue, and red. And so that is the level of the priority, like medium, low, and high. And we also have what we call a triage bot. So every single time, if we miss something on the channel and we haven't taken a look on that, so we will receive a notification to the channel, us mentioning, hey, there is something on the channel, on the triage channel that you haven't taken a look on. So this is like keeping us aware that there's things that we need to look on. So with this channel, it's just keep us transparent because this is a public channel. Everybody can see, everybody can join to the channel and follow up with discussion. And this is also keep us available to the developer. So one of the things that the developer can do in this channel is actually the question is searchable. So by going through this process and as we grow as a company, we're actually building knowledge-based information on the channel. So if the developer has some issue on the feature, they want to implement something, but sometimes they need some guidance. What they can do, they can first search on the channel and see if there's other people or other teams have a similar issue before, and see if there's any solution on that in the previous discussion. And then we also have what we call a feature channel. So this is a place where to discuss everything that is related to the feature. So each individual feature or project will have a different type of, it will have their own dedicated feature channel. So all of the people that is involved on this project are available on this channel. So it will have like a developer, QA, or PM, whoever that is working on that feature will be labeled in this channel. And so we also seen like multiple times where the security member has been tagged to the channel. It means that if they like tag our name on the channel, we will receive a notification, and they can just like ask questions by tagging our name. And what we can do is usually the security teams just can give some guidance like best practice or like how other companies solve a similar issue based on the context and based on their channel history on what are the things that they're discussing on the channel. So if you see through all of this process that we implement, so why does this matter? So it's actually really matter. So we have the process from the self-SDL where the development teams, they do their own check of the checking security when they're working on their features. So this helps the team itself to be thoughtful about the security when they're working on their project. And then we use a checklist to remind the developer for things that need to be looked on. And this also guides the developer to understand more with help of the security teams to complete the SDL. So as you can see, we use Slack, but definitely this process can also be adopted to other type of communication platform. And then transparency and also quick response help to build trust between us and the developer, and can be really helpful to build really good relationship with the development teams. And we also have an ongoing feedback. So this is keep us updated with the current trends of the security. So we always wanted to keep updated our checklist to make sure that if there's like a new issue coming up, we can give that information throughout all of the teams, not only for specific teams. So we have two different sources of our feedback. One is the internal feedback, which is actually from our development teams itself. So if we see more than one teams questioning one particular item of checklist, so it's actually a flag for us, meaning that we need to tweak that checklist and make it more understandable, fix the wording, so better to represent what is actually what we wanted to achieve from that particular checklist. And we also see the feedback from the development teams where, hey, why don't you just add this particular item to the checklist? So the checklist itself is not only coming from the security teams, but it's also can become from the development teams. So let's say we've seen a sample where our development teams, they're actually building a secure library to create a random generated string. So, and they think that that library can also be used by other teams. So we can take a look at the library and think that it's actually a secure library, and we can just add on the checklist to make sure that if there are other teams they wanted to do the same thing, they can just like use this library instead of rewriting the same thing. And yeah, once the checklist got updated, so any other teams, they can pick it up pretty quickly. And the way that we change the content of the checklist is pretty easy because on our tools, everything is actually based on a JSON description format. And we have an internal repository where everybody can take a look on the code, take a look on what is inside of the content of the checklist. And other teams can also create a PR, like a pull request to the repository, and then we can do the review if we want to add it. We think that it's a good suggestion, we can just add it to the checklist. And we have a couple of positive feedback from the developer about our process here. So things that we know, so our developers, they are smart, so they care about the products. And they also want to make it better and want to make it secure. But the thing is, they might not have a security background. So with the checklist that gives some kind of like inspiring security thought when they're doing the development, it really helped them to level up because they're actually doing the security work by themselves. And this is another positive feedback that we received from our developer. There's another one, which is actually, I think this one is in the pull request common. So we see more and more pull requests that is actually being tried to update the code when the developer realizes after they go through this SDL process. So once they look at the checklist, they realize, oh, there's something that we need to add on the code. We need to do the validation of the code. So we see more and more PR. So this pull request actually doesn't go to the security teams, but we just like look more and more on the PR that contain the SDL word on it. And it seems like we're pretty happy that our developers start thinking about security, even though that they don't have to go to the security teams. And we also have the bug bounty program. This is a really awesome program that we have. Highly recommended for other companies to have this program too. So this is where we receive constant feedback from our external user, where we make some mistake. And usually when we see something like we release some feature, usually we see more activity on the report, like some reporting for that particular feature. So it's almost like a constant feedback. When we release it, someone's taking a look on the feature. So we have a user from all over the world, and this also gives us exposure for researchers from all over the world as well. So there's a lot of smart people out there that we haven't known before, but they submit a really awesome report, really clever way to bypass something that we haven't thought about before. So this is like the source for us to get some kind of evaluation of our process. So once we receive a report, usually we try to figure out like what is the root cause of the issue, and then we fix the issue. And we also wanted to, try to figure out if we can add that to our checklist and see if it's applicable to other teams too. So we don't want to only fix one particular side of the code, but we also wanted to make sure that other teams, other people also understand that they should not do this or something like that throughout the organization. So yeah, this is a good place for us to get feedback for our SDL process. And this is the graph of our from our bug bounty program. So this is the number of the report that we receive starting from early 2014. So this is when we start the program. So when we started, we received like a lot of high influx of report. This is from our experience, and I think it might also be relevant for other companies too if they want to start the bug bounty program. Be prepared because you will receive like tons of reports, and from that report, not all of them is going to be a real bug. So, but this is the number of the real bugs that we received from the bug bounty program. So a little bit less, but the pattern of the graph is actually similar, or same. And I wanted to highlight more to this time frame, which is the last 12 months period. So from August last year to August this year. So this is like the number of the bug that we received. It's almost flat, but if we draw like a trend line, which will be shown on the next slide, it's actually like going downwards. So this is the number of, and this is the graph based on the number of SDL that got submitted through our process. So the SDL is actually slowly growing based on like how many features that we are actually pushing to the products. So so some of the months has a lower number of SDL, but that's depend on when we release the feature. So we combine this graph with this graph to become like this. Now this is the intersection between like how many SDL that got submitted and how many bugs that we receive from our bug bounty program. So as you see here, the blue one is actually the number of SDL, and the yellow one is the number of bugs. So from the trend line here, so the bug is like almost flat, but it's reducing pretty slowly, but the SDL is keep increasing. So we're pretty happy with the result of our SDL process here, which means that we're actually pushing more and more code throughout this year. So compared to the number of commits like from last year, we actually doubled the number of commit to the repository from our product, but we're actually introducing less bugs. So that's pretty good. And this is the total of the graph of the total of the SDLs that got submitted. So I think we already passed like 150 SDL that got submitted to our SDL process. And then what's next? So we are planning to open source tools that we're using. So the module and framework, hopefully it can be benefit for others. So we're actually working on it, and will be soon be released for open source. But actually the tool itself is really simple. It's pretty easy to rewrite if you take a look on this process that we shown you. And all of the primary source that we use for our checklist is actually all out there. We use OWASP, we use Microsoft SDL, and also Mozilla, and security coding guidelines. And then, so currently the way that we do the SDL is based on per feature. But we know that the way that we write new code is not only when we write a new feature, but we also write new code when we fixing bugs. So what we are trying to do is to build more in tooling, try to build more in automation to check whether or not we can we can detect the issue by automation instead of the checklist. So we can later on, but we're not there yet, later on maybe we can just like put everything inside of the automation pooling and then integrate it into your build pipeline. So we can just like remove the number of checklists that is necessary for the developer to take a look on. So, and that's all that we have for now. Thank you for joining, and hopefully this session is helpful for you guys. So feel free if you guys have any questions.
Yeah, so we've got a bit of time for Q&A. If anyone has questions, there's a mic in the middle, or if I can hear you, I can repeat your question. Yeah.
I'll just shout it.
Okay.
So you said you have 800 developers, a couple hundred developers, and still you manage all of that triage in a Slack channel with just the 3 of you?
So we have more than 800 total employees. We have about 400 plus people in the engineering org, so mostly developers. And so we have a triage channel for just our product security team. There are different triage channels that we use for other features. So sometimes discussions will shift over there. So if there's for the enterprise feature, that had a triage channel. But for people coming to us, they come to triage security or triage-security product. We are the ones hanging out in that channel, just waiting for responses. Yeah.
Follow up, so just to understand scale, what's the number of requests you get a day?
Messages to our team, probably just a couple per day. No more than 5 per day on average, but generally at least 1 or 2. And SDLs per day, also 1 or 2 SDLs per day. And the questions that come in may or may not be related to that. So sometimes it's a follow-up from a bug bounty bug we receive, or sometimes it is SDLs. Yeah. I could not catch that, sorry. There's a exactly.
Do you use CI/CD in your process? And if you do, how does it fit with this? When do they answer the survey, get this thing done?
So yes, we do. It fits in when there's a discussion with the product team generally. So a team will be planning their feature and then they'll do the SDL. Although right now we don't have that super solidified. So sometimes teams will formulate their project and then do the SDL when they're starting to code. Sometimes they'll come to us first, ask a bunch of preliminary questions, then go and do the SDL. So for new features, it's generally right before coding starts, but it is sometimes right after, sometimes it's a little bit later. But there was a previous discussion which allowed there to be enough context where we said, oh yeah, you can start, let's make sure we get this, but you've talked to us enough, and that's kind of the in-person SDL equivalent. So that's one of the future goals, is have a bit more regularity with this process. Yeah.
Check that. It sounds like the series of checklists you get. Maybe one with what language are you using, and then another checklist that will be that, and another checklist. Is that right?
Yes.
And how long is the checklist?
Depends on the section, so it could be 10 questions. What's the? So the question was, so you start a checklist, and then how many questions follow, and you start with a certain language, and then there are logical follow-up questions. So yes, so we won't give you a bunch of C questions if you say yes, your language is go. Total number of questions will vary.
I think it's a very we don't have more than 10 checklists per one item. So I think we keep it last number for the checklist.
10 checklists or 10 items per checklist?
Less than 10 per item. So let's say they check PHP language, it might have less 10 checklists for PHP language.
Yeah, also when we open source this, we'll be releasing the JSON that we're using as examples, because most of it generalizes to, actually I would say 99% of it is generalizable, and then it's very easy to spend more time thinking about what security topics you want to address as opposed to how to actually write it. So you just say, oh, these are the things we're concerned about, throw them in a JSON file, put them in the repo, or put them wherever you're running the tool, and then they're there. Yes?
So if I understand correctly, the checklist is not tied to actual releases, it's tied to the project?
Yes, so the question is the checklist tied to releases of projects? It's tied to projects. Our releases are more just features or ships.
Yeah.
So we,
Yeah, so my question would be, how do you capture deltas? And if the checklist was completed by somebody a long time ago, and there are new developers on the team, and they're releasing features, how do you make sure that they actually understand what they are supposed to do?
so the question is about if the checklist is completed in the past and then features change or more developers come on, how do we track that? I would say that is a minor gap currently. So it's in that it's knowledge that's kind of in our brains as opposed to in the process or documented somewhere. So if we see an SDL that's come about very early, but then they decide they're going to release the feature, or they're wrapping up the feature months later, or a PM has changed, or the core engineers have changed, that's something we're aware of and we'll deal with, but there's not a part of the process yet that does deal with that. So that's something we are aware of. We want to improve our process as well, because sometimes you have roadblocks or reprioritization, and the SDL gets completed, and then months later we've got the team working on something. So we'll say, hey, yes, you should do this again, or hey, let's just sync up and make sure we're all on the same page. But that's kind of implicit knowledge as opposed to mixed. And that's all the time we have right now for Q&A, but our contact information exists somewhere. My Twitter is Mrs. Bufferworks, so you can tweet me if you can't remember any of our emails, and we're happy to respond. So thanks everyone for coming. Have a good rest of the show.